So I am going to use the H version going to 0 to do this, but there's also this alternate version, and you never know which is easier to try both, but I'm going to go for this one. And when I do this one, I recommend we do a 3-step process. First, we figure out what the heck is f plus h. Once we get that, then we try to subtract the original function. Once we clean up that, we try to divide by h. And once we get all that done, then we try to take the limit. So step 1. What the heck is f of x plus h? Well, the trick to that is do f of parentheses equals 2 parentheses cubed minus 2 parentheses. Just rewrite the function with parentheses instead of an x, and then stuff the x plus h in each spot. Oops. Okay, so cubing x plus h, there you really just got to do that. And depending on your pre-algebra, pre-calculus class, you might have learned a shortcut for that. That right there is going to be x cubed plus 3x squared h plus 3xh squared plus h cubed. And I have 2 times that. And if you're wondering how the heck I did that, it's called the Binomial Theorem, which is covered in some pre-calculus classes. I'm going to distribute here. So that's minus 2x minus 2h, and then minus 5. If you're uncomfortable with me just writing that down, then your alternative is to take x plus h times x plus h times x plus h, multiply those two, and get x squared plus 2xh plus h squared, and then multiply that by the other one. And you will end up at this conclusion right there eventually. All right, so I got to distribute the 2 through there. So 2x cubed plus 6x squared h plus 6xh squared plus 2h cubed minus 2x minus 2h minus 5. And there's no like terms here. So that's the best I can do. So that's step 1. All right, step 2 is to subtract the original function. So I want to subtract each of these terms. So I think I'm just going to line them up underneath. So I need to subtract 2x cubed. So right underneath, I'm going to write, so this is step 2. I'm going to subtract 2x cubed. And then I need to subtract negative 2x, which means I need to add 2x. And then I need to subtract negative 5, which means I should add 5. And notice that just pulls the original function out, right? A number minus itself, gone. Negative 2x plus 2x, gone. Negative 5 plus 5, gone. So after step 2, I have 6x squared h, or during step 2, not after, I'm in step 2, 6xh squared plus 2h cubed minus 2h. Do I got them all? I got that one, that one, that one, and I got that one. Can I do anything else to this? The answer is yeah, they're all even and they all have an h. So that is going to be 2h times 3x squared plus, say I'm pulling the 2 out, 3x, and I'm pulling one of the h's, h, plus I'm pulling the 2 and one of the h's, so that'd be an h squared. And then here I get a minus 1 because I'm pulling out the 2 and the h. And that's it. Okay, so there's step 2. Step 3, we try to divide by h. So for step 3 here, I'm just going to write underneath here, divide that sucker by h. And that's fortunate because I just pulled an h out in the top, which will divide with the h in the bottom. A number divided by itself is 1. Dividing by 1 is lame. So this right here is, the 2 is still there, parentheses, 3x squared plus 3xh plus h squared, just minus everything that was in the parentheses is still there. I just lost the h, but I still have the 2 dividing by 1. Who cares? Okay, step 3. Step 4 is to actually take the limit as h goes to 0 now. So let's put a little line in the way there, or squiggle. I now want to do the limit. Let's switch to a different color. Let's use blue. The limit as h goes to 0 of 2 times 3x squared plus 3xh plus h squared minus 1. And at this point, we should be ready to cheat and just throw the h in. So as we take h to 0, this is 0 times 3x, which is 0. 0 squared is 0. So it looks like the limit is 2 times whatever's left. So 2 times 3x squared is 6x squared. 2 times negative 1 is, oops, not plus, but minus 2. So that right there should be f prime of x. Well, that was fun. So I got this part right here. I got the first derivative, 6x squared minus 2. And now this says take the derivative of that. So now I need to take its derivative, new page. So new page. So I started with f of x equals 3x squared minus 2x minus 5. And I just discovered that f prime of x is 6x squared minus 2. Now I want to figure out what is f double prime of x, which means take the derivative with respect to x of 6x squared minus 2. So to do that, we have to take the limit. I'm going to use the same definition, the h version, as h goes to 0 of the f of, we shouldn't call it, let's call this one g of x. And so the second derivative would be g prime of x. And so then over here, we'll call this g of x plus h minus g of x all over h. And again, you know I don't like to plug in all at once. I like to do it in steps. So let's go with step 1. Step 1 is what is g of x plus h? So do g of parentheses would be 6 parentheses squared minus 2, and then drop in your x plus h. And we've squared x plus h a lot of times now. Hopefully you're getting pretty used to that. That's going to be x squared plus 2xh plus h squared. And then we need to multiply that by 6 and then subtract 2. So that's going to give me 6x squared plus 12xh plus 6h squared minus 2. And I could factor a 2 out. That's not that exciting. I think I'm going to choose not to factor the 2 out at this point. Just go with that. Okay. Step 2. Subtract the original function. So I'm just going to line up. So here's my original function right there. I want to subtract the 6x squared. So I'm going to write subtract 6x squared underneath. And I want to subtract a negative 2, which means I'm adding 2. And notice with polynomials, that means I get to pull the original function, the pieces of the original function out of the x plus h version. So that's going to give me 12xh plus 6h squared. All right, step 3, divide by h. So for step 3 here, I'm just going to divide this whole thing by h. Oh, I'm a little premature, aren't I? I am, but I'm just going to go with it anyway. No, I'm not. I'm premature. I'm not ready for step 3. I lied. I can factor this. Up here, I could only factor 2, which wasn't that exciting. But here I can factor out an h and a 6. That's exciting. Okay, that's a lot more fun. So this right here is equal to 6h times, we still have a 2x. We took the 6 and one of the h's, so plus h. Oh yeah, that was totally worth it. Yeah, good thing we backtracked. Now we do step 3 and divide by h. And yeah, h divided by h is 1. Dividing by 1 is not that thrilling. So now I have 6 times 2x plus h, and I'm ready to do the limit, step 4. So what is the limit as h goes to 0 of 6 times 2x plus h? Well, if h goes to 0, then I just get 6 times 2x, which is 12x, and that has to be the second derivative of this function. Yeah. All right. Now, I just want to backtrack a little bit. I want to graphically compare the function and its first derivative, because you had a few questions like that at the beginning of your homework. And now that I have an actual equation, Desmos will shed some light on some things here. All right, let's go to Desmos. Actually, no, I think I want to go to GeoGebra today. Do GeoGebra. Let's shake things up a bit. GeoGebra. And the reason I'm going with GeoGebra, because it's easier for me to graph a tangent line in GeoGebra than it is in Desmos. All right, so I got f of x equals 3x. No, that's a lie. What was it 2x? No, I forgot. 2x cubed. Oh yeah, that's right. 2x cubed minus 2x minus 5. Hello? What happened here? Oh, there it is. Whoa. Okay, so there's my function right there. And let's zoom in. Oh, wrong way. Zoom in on that a little bit here. All right, so I can see it's got positive slopes down here, negative slopes in the middle, and then positive slopes over here again. So its derivative function should go from positive to negative to positive. So it should have some zeros in between. Now I want to throw a point on this function. So I'm going to throw a point right here. And then somewhere there's a tangent line button in here. Where is it? Tangents, that one right there. Select the point or line, then the circle, conic, or function. Okay, so point and function. Yeah, look at that. Isn't that awesome? Tangent line, sweet. All right, then I can switch to the move tool and I can grab this and I can move it. Now, even better, whoa, it gets a little wiggly right there. Should probably zoom in a little more. Let's change the scale. Let's do this. We're gonna scale the Y. Oops, I want this move tool. Other cool thing about GeoGebra is if you use the graphics move tool, then you can rescale the axes. So I'm gonna rescale Y, isn't that freaky? Whoa, it's bending my mind. And then we'll scale the X the other way. Whoa, isn't that cool? Oh my gosh, I love math. All right, and we can also move it around. All right, so there it is there. So now I can manipulate it better. So back to the move tool, positive slopes. And actually they have a slope measurer here. Let's go to more. Oh shit, wrong button, sorry. More slope. And I just select the line I want the slope on, that one. Yeah, so I can see the slope's like 10 right there. And then get the move tool. And then eventually the slope's gonna drop. It's a little hard to read there, unfortunately. Oh, it's hard to read because I put the slope in more than once. Let's get rid of this one. That's better, okay. And then, yeah, so +2 is the slope, and then all of a sudden it gets shallower and shallower and shallower until somewhere over here-ish, the slope's gonna be around 0. It's gonna flatline. Come on, flat line, somewhere in there. And then the slope jumps to negative, 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 negative. And then all of a sudden it's going to go shallow, zero slope somewhere in here, and then it goes positive again. So I want a function that goes from positive to positive again. And my claim is that function is, I'm going to call it g of x here, and it is 6x raised to the second power minus 2. That function right there. And notice this function right here has a 0 at about negative 5.77. And if I take that point A here and I drag it over to negative 5.77, oh, where'd my tangent line go? GeoGebra, what happened? Freaked out on me. I lost my tangent line. Let's put it back in. Oh, I bet it called the tangent line g of x and I screwed it up. That's probably what happened. Tangent line. Where'd you go? Where'd it go? I'm missing it. Oh, it's up here. Tangent. There we go. Tangent, point, curve. There we go. And so if I set A to 5.77, I should get a slope of 0 there. I'm kind of in the right spot there. Oh, I am. Cool. All right. So just wanted to get across. So the green is the original function. It's a cubic. The derivative is a parabola type function, quadratic function. And anywhere that the original function peaks or valleys, the derivative function should have a 0 because we change slope from positive to negative or negative to positive. That's the moral of this story in addition to all that fun algebra. Thanks for playing.